Hey guys, day 3 of unit 9. Okay, so yesterday we looked at linear functions. Today we're going to look at quadratic functions. Okay, so just like we've done in the first semester, we're going to look at just our parent function, f of x equals x squared. Okay, so let's look at that. So plug in some x values, get some corresponding y values. Oops, doesn't want to be that zoomed in. All right. X is -2, y is 4, x is -1, y is 1, 0, 0, 1, 4. These should be familiar points. There is our x squared parabola. It has a vertex of 0, 0. Now we are going to state the domain and range. Recall the domain is the x values. Okay, so what x values does the graph touch? Well, it does technically go on forever, left and right. So the domain is all real numbers. Now for this one is range. What are the y values that the graph touches? Well, it starts at 0 and it will go forever up. So y will be greater than or equal to 0. Okay. Now this graph will change. So let's look at some changes. All right. So if I give you f of x equals -x squared, you know that it's going to flip or it's going to reflect. Okay. So one thing you can do is if you can do the points by hand, or you can use the calculator to get points. All right. So one thing that happens is 0, 0 still the vertex. All right. That doesn't change. It's going to flip over the x-axis. Well, the vertex is already on the x-axis. All right. So notice that point 1, 1 is going to flip to 1, -1. -1, 1 will flip to -1, -1. Then the other points will flip. Okay, and if you want, you can get these points from your calculator. Nothing wrong with that. So that's what the graph looks like. Okay, so what happened? What changed? Well, it was reflected over the x-axis. Okay, so the domain, all right, well, the domain is all real numbers. That does not change. The range changes a little bit. Instead of going up forever, now it's going down forever. So it'll be y is less than or equal to 0 instead of greater than or equal to 0. Okay, all right, let's go ahead and look at the next one. Remember, since this is a video, at any time you can pause it and rewind it. Next one, f of x equals 2x squared. Okay, 2x squared. So it is going to get skinnier. Okay, it's going to get skinnier. So remember, get these points from your calculator, or you can always just plug in the points. All right, if I wanted to plug in the points, well, I'm going to do the same points. Okay. -2 squared is 4 times 2 is 8. -1, 2, 0, 2, 8. Okay, those are my points. Really, I just want to focus on these three, especially since it doesn't go, the graph doesn't go to 8 on the y-axis, and that's fine. Here's what my graph will look like. Again, use your calculator if you need to. Nothing wrong with that. So notice that when this was 1, this right here was 2. Okay, this was 2. All right, so what that means was the change was it was vertically stretched by 2. Okay, or multiply by scale factor of 2. You'll hear that a couple of different ways like that. All right. vertex is 0, 0. The domain is still all real numbers, and the range is y is greater than or equal to 0. Okay, y is greater than or equal to 0 for the range. All right, now let's look at the next one. It says f of x is 1/2 x squared. Okay, well, get your points if you want. Use your calculator. I'm gonna do them here so that you can see them. So this will be -2 squared is 4, half of 4 is 2. -1 squared is 1, half of 1 is 1/2. 0, 0, 1, 1/2, 2, 2. Okay, so 1, 1/2. Yes, you can graph a half. Nothing wrong with that. 2, 2, 2. So your graph looks like this. Okay. There was what's called a vertical shrink by 1/2. This could also be called a compression. Okay, each point was half the distance from the x-axis as the parent function. All right, the vertex is still 0, 0. Domain is all real numbers, and the range y is greater than or equal to 0. Okay, all right. Hopefully this is making sense. Let's go to the next page. We're going to look at 3 other examples here. Okay, 3 other examples. Oops. So this one says f of x is x minus 3 squared. So remember our rules. Okay, what's happening here? Well, there are parentheses. Since there's parentheses, it's a horizontal shift. So that means left or right. Okay, so I'm going to say it's going to shift, and since there's parentheses, it's the opposite, right 3. Okay, so as we move on, really you just need to focus on those 3 points, 0, 0, 1, 1, -1, 1. So I'm going to move those 3 points right 3. So 0, 0, 1, 2, 3 goes to there. 1, 1, 1, 2, 3, right 3. -1, 1, 1, 2, 3, right 3. Okay, and as always, check it using your calculator. So there's my parabola. That was terrible. A little better. All right. Then write down where the vertex is. Well, the vertex is at 3, 0. The domain, still the same. All real numbers. It's touching every x value. The range, y is greater than or equal to 0. Okay. So notice that your range is always connected to the y value of your vertex. Okay. Let's look at the next one. Okay, we're going to graph y equals x squared plus 2. Y equals x squared plus 2. All right, well, there are no parentheses, so this is what a vertical shift. So it's going to shift up 2. So you're going to take your 3 points and move them up 2. So 0, 0 goes here, up 2, 1, 1, up 2, -1, 1, up 2. So there's my new parabola. The more you do this, the better you'll get at it, I promise. All right. Okay, so it has a vertex of 0, 2, has a domain of all real numbers, and it has a range y is greater than or equal to 2. Change from 0. Notice the y coordinate of the vertex. It's always connected to the range. Okay, always connected to the range. All right. If you want to challenge, you can pause it and try the next one on your own. If not, just watch me. But either way, let's do the next one. F is equal to f of x is equal to -2, quantity x plus 1 squared plus 2. Okay, so there's lots of things happening here. All right, there's parentheses, so it is going to move left 1. Okay, there's a vertical shift. It'll move up 2. Okay, it will be reflected over the x-axis. That's the negative, and there is a vertical stretch by 2. Okay, there's a vertical stretch by 2. Okay, so I like to always apply the movements or the transformations to the vertex first, so 0, 0. So it can't be stretched or reflected, so it's going to move left 1 up 2. So there's my new vertex. All right, now let's talk about how to move that point 1, 1. Okay, how to move that point 1, 1. So the first thing you want to do is you want to stretch it, reflect it, and then shift it. Okay, so if the point's at 1, 1, okay, here, it's going to be stretched to 2, then it's going to be reflected down here, then it's going to go left 1 and up 2. So the resulting point will be there. Okay, so I want to see that again. So here it was stretched to 2. Watch the cursor. Reflected all the way here, up 2, left 1, up 2, either way. So there's that point. Okay, now let's look at this point. We're going to do the same thing. We're going to stretch it to 2, reflect it, up 2, left 1. Okay, and again, if this seems too hard, use your calculator to get the points. Okay, but the more you do this, I promise you're going to want to just do it by hand. So there's my parabola. Okay, it has a vertex of -1, 2, has a domain of all real numbers, has a range that is less than or equal to +2. Okay, so it's a little difficult because there's 4 things happening, but you guys are smart. I'm confident that you can handle it. All right. I'm going to look at this one, and then we'll shift gears just a bit. Okay, we're going to look at this one, then we'll shift just a bit. All right, so first describe what's happening. Well, it is going left 2, there's parentheses, horizontal, inside the parentheses, opposite. It's going down 1, and it is a negative out front, so it is being reflected over the x-axis. Okay, all right, so I'm going to move that 0, 0, left 2, down 1. Okay, and here's what I want you to do. I want you to ignore those parentheses. Those are unneeded, so really it should just be -x plus 2 squared minus 1. Okay. Then you're going to take this point 1, 1, and you're going to reflect it, and then you're going to move it left 2, down 1. Okay, you're going to take this point, you're going to reflect it, left 2, down 1. Here's the new parabola. The vertex is at -2, -1. The domain is all real numbers. Range is y is less than or equal to -1. Okay, so again, ignore the parentheses. If you need to use your calculator, check it. All right. All right, now we're going to shift gears just a bit. So these next examples says writing equations of quadratic functions. So the directions say write an equation that moves x squared left 4 units, up 1 unit. Okay, so you can kind of use your formula here. So we got a formula for this. All right. H moves it left to right, K moves it up or down, A stretches or compresses it, and also reflects it. So if it's moving left 4, there's going to be parentheses. It's going to be opposite, up 1, looks like that. Okay. Let's look at the next one. It says write an equation that stretches x squared by a factor of 5, moves it right 6 and up 2. Well, if it stretches it by a factor of 5, there's a 5 out front. Since it is moving right, there's parentheses. Right 6 means opposite, so x minus 6. Up 2 plus 2 for your k value. All right. So I want you to hit pause now and try the next two, and then I want you to check them. So go ahead and hit pause now. All right, check your answers. That's what you should get. In the past, I found my students have the least amount of trouble with problems like this. Just make sure you don't leave off the squared, make sure you read carefully, look at your equation, and make sure it matches the description. Okay. All right, last page of our notes. We're going to look at two graphs and answer the questions. All right, so this one says, find the factor that x squared has been multiplied by. So we want to see if it's been stretched or compressed. And it definitely looks like it has been stretched. So remember, we always want to look at 1 square for x, and then where that next intersection is. So that intersection is right there. So it's 1, 2, 3. So instead of 1, 1, it's 1, 3. So it has been multiplied by a factor of 3. Okay, it's been multiplied by a factor of 3. It's stretched 3 times the distance from the x-axis. All right, last one. Again, we're going to look at 1 x squared, and then we're going to look at this one. So we're going to look at that point right there. So it's not 1, it's half the distance. So this one's been multiplied by a factor of 1/2. Where it's been compressed half the distance from the x-axis. Okay, so hope that makes sense. Tomorrow is the last day that I do have to be gone. Thank goodness. Hope you guys are doing great. Miss you. See you soon. If you need anything, please email me.